Hi, I'm Haocheng Wang. I'm from Group 23. Together with my teammate Xianzhi Zhang, we are now presenting you our Part B's final result. In Part B, our goal here is to make our worker walk longer in rough terrains. In other words, the worker shall behave more stable. However, at least for our group, we do not find the direct relationship between all these adjustable parameters and the stability behavior of this passive worker. Instead, we find the relationship between the dynamic behavior of this passive worker and all these adjustable parameters. So, to determine our worker's design, we basically iteratively observing the falling of our worker. Then, we accordingly adjusting our dynamic behavior by adjusting our design parameters. Here in our work, we mainly focus on adjusting the hip leg weight ratio and thigh shank length ratio. This is because, as the table previously suggested, their contribution to the overall dynamic of this worker is quite predictive. We also changed the foot diameter and foot position. This is because, as McGill has suggested in one of his later paper, the epsilon k here is quite important for maintaining a stable walking behavior. And our design does yield an improved behavior. As we can see, the red walker, which is the one we designed, worked a bit further than the one designed in A. We also made a MATLAB plot to show this more precisely. Considering that the first 10 meters are all of smooth terrain, the walker we tweaked goes roughly 50% further. Within that 10 meter smooth terrain, if we compare these two walkers, we can also clearly see that at the beginning, the walker with B's parameter goes into the limit cycle much faster than A. We can also see that the step length and step period all change. This correlates to the table we previously mentioned pretty well. However, changes we made still has limitations. For example, the epsilon k we changed, though it is important for stable walking, it also simultaneously decreased the foot ground clearance, which is no good for rough terrain. Also, because step length shortened, though the system made within one step becomes more stable, it effectively needs more steps to finish one piece of length. This could exponentially worsen behavior in some certain conditions.